So let us solve this problem. Okay, let us prepare a sketch of this given cross section of a dam and the pressure distribution diagram for water pressure and also uplift pressure and the tailwater pressure. So the new problem in this point is drainage gallery is shown, okay, and we have to calculate uplift pressure with reference to the position of drainage gallery. So let us prepare a sketch for this. Here various levels are shown. Okay, so with reference to these levels, let us find out the height of the dam, okay, height of the water in the dam. So see here in this figure, maximum water level is given as 285 RL, whereas the base of the dam is 205 RL. So what is the height of water in the dam? Yes, find out this. What is height of water in the dam? What will be the height of water in the dam with reference to this given RLs? It is 80 meter. Correct. So this height of water is 80 meter. Then what is the freeboard here? Okay, what is the value of freeboard? So that we can calculate RL at the top, which is 289 minus maximum water level 285. Hence the height of freeboard is 4 meter. Similarly, we can find out height of this roadway. So what is the height of roadway? So that we can find with respect to these two RLs. Okay, one is 289 and other is 280. So height of roadway is 9 meter. Okay, and then what is the total height of dam? Total height of dam is 84 meter. 80 plus 4, 84 meter. Then it is given that there is a tailwater. So what is the height of tailwater? See, this elevation is 211 and this is 205. So height of tailwater is 211 minus 5, that is 200 and that is 6 meters. Okay, this height is 6 meters. Now let us prepare the pressure distribution diagram for the water in the reservoir and tailwater. Okay, let us start with the water in the reservoir. Here the upstream face of the dam is vertical. So that's why its distribution will be triangular one. So this is the water pressure distribution diagram. So this is PW, horizontal water pressure on the face of the dam. Similarly, we can show the distribution diagram for tailwater. Okay, so this is the tailwater pressure. Let us say PW dash. PW H dash. This is okay, and this is inclined phase, so there will be one more vertical component of water pressure, and that is PWV. Okay, so now we will show the uplift pressure intensity diagram. So we know that this uplift pressure intensity diagram is a triangular one if tailwater is 0. But if there is a tailwater, in that case, it is not 0, it is having certain value. So let us draw tailwater distribution diagram, uplift pressure distribution diagram. Now see here, this top width of the dam is given as 6 meter in the problem. So this is also 6 meter. Total distance is shown as 56 meter in this. Okay, and drainage gallery is at a distance of 8 meter from upstream face of the dam. So we have to mark that line of position of drainage gallery. So this is the position of drainage gallery, and it is at a distance of 8 meter from upstream face. Okay, and we know how to calculate the uplift pressure intensity at all these various points. Okay, the uplift pressure intensity at this point, that is at the hill of the dam, it is given by W into H. Okay, and here at other end, that is at the toe, it is given by W into H dash. So this value is given by W into H dash. Then the value of uplift pressure at a drainage gallery. So that is given by, see this particular height. This is given by 1/3 the difference of uplift pressure between hill and the toe. Okay, let us first complete the diagram and then we will calculate the values. This is the uplift pressure distribution diagram. And now using these three diagrams, we are going to calculate all the forces. Okay, this is the diagram showing all the forces. Now, which are the forces? Primary forces are self-weight of the dam. So, show self-weight of the dam at the CG of this rectangle and triangle. Self-weight of the dam. W1 and W2. After the self-weight, next force is the horizontal water pressure. So that is PWH already shown. PWH dash is also shown. And also we have to calculate weight of water on downstream phase. So this PWV we have to find out. Along with this, we have to calculate uplift pressure. Here we can calculate this uplift pressure by dividing this composite figure into some regular figures. Okay, let us divide this figure into some regular figures. Okay, and now these regular figures are U1, that is trapezoidal portion, U2 is rectangular portion, and U3 is a triangular portion. Okay, so these forces we have to consider: uplift pressure U1, U2, U3, then self-weight W1 and W2. After that, weight of water on downstream phase. Let us say this as a PWV. And now we have to find out all these forces. So now we will write all these forces in a table format. Okay, and for that, this is the table format. Designation used for the force, then dimensions. Next column is vertical force, in kilonewton. Next column is horizontal force in kilonewton. Next is the perpendicular arm or lateral arm in meters. Next is movement about 2. Movement about 2. Okay, and we will write the positive and negative movements in different columns. Okay, so in previous problem we have solved these in steps. So now we will write all these values in the table format so that the calculations are easy. Now let us start with the self-weight. Of the dam. And in that you calculate W1 and W2. Then you find out the vertical component of water load due to the triangular column weight of water on downstream face. That is denoted as it is PWV. PWV dash, weight of water on downstream face. Okay, then uplift pressure. Okay, in that we have used the designations U1, U2, and U3. And then next is water pressure. For that we have used the designations P1, WH. Okay, we have used designations PW and PWH dash. Okay, now calculate the self weight first. Okay, start with W1. Okay, tell me what is the value of W1? What is W1? Calculate W1. W1 is what? It is a rectangle. Okay, and what is the size of rectangle? It is 6 meter by 84 meter into unit length. Unit length is 1 meter. Okay, total height is 84 meter and width of that rectangle is 6 meter into unit length, that becomes volume. And here it is mentioned in the problem that the unit weight of concrete should be taken as 23.5 kilonewton per meter cube. So hence calculate W1, tell me the value of W1. Yes, correct. W1 is 11844. See how W1 is calculated. Area of rectangle into unit length into unit weight of concrete. And hence it is 11844. Then W2 is a triangle. W2 is a triangle. See what are the dimensions of the triangle. Its height is 84 minus 9. So that is 75 meters. And see how much is the base. This one is 6 meter. Total is given as 50 meter. 56 meter. So that's why base of the triangle is 50 meter. Is it clear? Total height is 84 minus 9. That's why it is 75 and base width is 50 meter. Total is 56 minus width of rectangle. That is 6 meter. So area of this triangle is 1/2 50 into 75. Into unit length 1 meter and into unit weight of concrete 23.5 kilonewton per meter cube. And by solving this, we get this value as 44062.5. Okay, these two are the vertical forces and they act vertically downward. And vertically downward, we took this as a positive. That is the sign convention. And vertically upward, negative. After that, calculate weight of water on downstream face. Okay, so weight of water on downstream face. So we have to take the area of triangle. Okay, which triangle? C. So in the given problem, this height is 6 meter and this is 4 meter. Okay, so 4 meter and height is 6 meter. And that's why area of this triangle is 1/2 into 4 into 6. Into 1 into 23. No, not 23, it is 9.81. It is a weight of water. And this calculation is 117.7. After that, U1 is uplift pressure for the trapezoidal section. Okay, it is a for trapezoidal section. Then U2 is for rectangular section and U3 is for triangular section. Okay, let us calculate W into H first. So tell me what is this value, W into H. Yes, tell me. We are talking about the calculation of this. Calculate the value W into H. What is W? It is 9.81. And H is small h, that is the height of water. So what is W into H value? What is height of water here? See this gauge. Height of water is 80 meter and W is 9.81. Okay, so it is 784. 784. So what is this 784.8 value show in the figure? See, this total height is W into H, and this value you have worked out as 784.8. Okay, so now we have to separate from this U2. For this, we have to find out what is this vertical height is. Okay, and for that, what is the formula for uplift pressure at the gallery? Okay, we know that the formula is here. Uplift pressure at the gallery is given by W into H dash plus 1/3 of H minus H dash. Okay, so we have discussed already this point. If there is a drainage gallery, in that case, at the drainage gallery, uplift pressure is given by, or it is an addition of uplift pressure at the toe of the dam, that is W into H dash, plus 1/3 the difference between the hill of the dam and toe of the dam, that is W into H minus W into H dash. या दोन्हीचा difference 1/3 portion plus W into H dash. Okay, so use this formula and calculate this value. Everybody calculate this value. So what is H dash here? H dash is 6 meter, that is tailwater height, and H is 80 meter, that is the height of water on upstream side. So put these values of H and H dash, then you know that this W is 9.81. So calculate this value. Yes, immediately calculate this value. The formula is given to you. Okay, correct. So by putting these values of H, H dash and W, we get this total uplift pressure component at the drainage gallery as 300.84. Okay, this is 300.84. So this vertical height is 300.84. Now we can calculate U2. Okay, U2 is a rectangle. So size of rectangle is here 8 meter by 300.84. Okay, so let us calculate U2 and write this U2 first. So what is U2? U2 is 300.84 into 8, and this is equal to 2406.7, and this is upward force U2, hence give minus sign convention. Now we have some dimensions for this pressure diagram. Okay, so what is this part? This part is 300.84. Total is 784.8. So calculate this remaining part. That is the height of U3. So now tell me what is height of U3. It is 784.8 minus 300.84. So what is that value? It is 483.96. 483.96. So this is the height of triangle, and base of triangle is 6 meter. Now we can calculate base of triangle is 8 meter, not 6 meter. It is 8 meter up to the drainage gallery line. So from this we can write U3. U3 is equal to what? Area of the triangle. So it is 1/2 into base 8 into what is the height? Height is 483.96. So now tell me what is U3 value. Yes, correct. U3 value is 1935.84. And this force is again upward and sign convention is negative. Now let us calculate U1. So what is essential to calculate U1? Okay, observe the figure U1. So U1 is a trapezoidal shape. Okay, so how to calculate U1? So for that we have to take average of these two values. We know that this particular height in this triangle is, okay, this particular height is 300.84. Okay, and calculate also this W into H dash. What is this value? H dash is 6 meter here. So 9.81 into 6. It is 58.86, correct. 58.86. Okay, and we know that the base width is 50 meter. Is it clear? Base width is, okay, it is not 50 meter. It is 56 minus 8. Total is 56 minus 8 meter. So how much it is? 48 meter. Okay, so this is 48 meter. So now we will calculate U1. So how to calculate U1? We will take average of these two values. 300.84 and 58.86. We will take average of this into base width 48. So let us write for this. At first take average of these two values, that is 300.84 plus 58.86 divided by 2 into 48 meter. Okay, and this comes out to be 8632.8, and this is also upward, so it is negative. Okay, and now we have to calculate the water pressure, horizontal water pressure, PW. So we know that it is given by WS square by 2. PW is given by WS square by 2. So here W is 9.81 into H is 80 square by 2. And by solving this, we get the horizontal water pressure component. It is a horizontal force. So write this in the next column. 31392. Direction is towards right. Then PWH dash, it is a tail water pressure. Okay, and here it is given by WH square by 2. So W is 9.81, H is 6 square, and divided by 2, WH square by 2. And if we calculate this, then this value comes out to be 176.6 kilonewton, and direction is towards left. Okay, so show the directions for the horizontal forces. So after calculating all the forces, now from this, here it is not asked to check whether it is safe against sliding and overturning. Only here it is asked to calculate the maximum stresses and at the toe and the hill for full reservoir condition. So we know that to calculate this, we have to calculate X bar, and to calculate X bar, at first we have to calculate summation V and summation M. So what is summation V? Summation V is summation of all vertical forces. Okay, so here we have worked out all vertical forces. Some are positive, some are negative. So take algebraic sum and tell me what is the value of summation M. Sorry, summation V. Yes, immediately tell me what is summation V. Simply you take algebraic sum of this column, vertical forces. Okay, there are some positive values, there are some negative values. So take summation of this and tell me what is summation V. Calculate summation V, and then we will go for summation M. Yes, only 5 minutes are left. See, there are 3 negative values and 3 positive values. Okay, positive values are 11844, then 44062.5. Okay, these are the 2 positive values. 117.7, that is again positive values. All these three forces are vertically downward. So take addition of these 3 and take addition of remaining 3. Okay, and see what is the difference between these 2. So how will you calculate this? 11844 plus 44062.5 plus 117.7 minus 8632.8 minus 2406.7 and minus 1935.84. So tell me, what is the summation? Yes, correct. It is 43048.9. Similarly, you can calculate summation of horizontal forces, summation H. Okay, so consider forces acting towards right positive and towards left negative. So take algebraic summation of these two forces. This is positive and this is negative. So 31392 minus 176.6. And what is the answer? Here answer is 31215.4 kilonewton. Direction is towards left. Summation V is also positive, so direction is downward. After getting summation H and summation V, now we'll see how to calculate summation M. Okay, we know that summation M is algebraic sum of the writing moments and overturning moments. Okay, writing moments we will use plus sign, which are, okay, let us calculate first, then we will see how to get this. So everybody again observe the figure, because here we need what is the perpendicular distance for all forces. So let us start with the W1. We have to find out what is the lateral arm, what is the distance of force from toe of the dam. So tell me, what is the distance of self-weight from toe of the dam? See this figure and tell me what is the distance of W1 from toe of the dam. Okay, this is W1 and this is the toe of the dam. So what is this distance? This is 50 plus half of width of rectangle. Hence it is 53. Okay, so write in this column for W1 it is 53. Then what is for W2? Again see the figure. Where is W2? So for W2 we have to take its distance from toe as 2/3 of the base. Okay, it is 2/3 of the base. So calculate this distance and tell me the value. 2/3 of base of triangle. Yes, what is this value? Distance of W2 from toe. 2/3 of base. Base width is 50 meter. 2/3 of 50. So what is that value? It is 33.33. Correct. Okay, now take movement of these two forces with respect to toe. So it is force into perpendicular distance. 11844 into 53, and answer is 627732. And how this W1 creates movement with respect to toe? So with respect to toe, it creates anti-clockwise movement. So for anti-clockwise movement, we are using positive sign. So hence write positive movement. Write this in positive movement column. 627732. Similarly, 44062.5 into 33.33. So this comes out to be 1468750. Okay, both are creating clockwise, anti-clockwise movement with respect to toe of the dam. Similarly, next is PWV. It is 117.7. Okay, now tell me what will be its perpendicular distance of PWV from toe of the dam. Okay, see, this is PWV and this is toe of the dam. Okay, so width of the base of this triangle is 4 meter. So from the toe we have to take 1/3 of base. So it is 4 by 3. So 4 by 3 is equal to how much? It is 1.33. So 117.7 into 1.33, it is 157. And it also creates clockwise movement. Okay, resisting movement. Then the moment of uplift pressure, U1. See what is the position of U1 in the figure. Okay, this is U1. Okay, so time is up now. So let us stop here. So you complete the remaining problem. What you have to find out now? What is distance of U1 from the toe? What is distance of U2 from the toe? What is distance of U3 from the toe? And then you have to calculate the movements due to U1, U2, U3. And at the end, you have to calculate movement due to PW and PWH dash. So when you calculate all the movements, now here movement due to uplift pressure and the horizontal pressure will be clockwise with respect to toe. So that you have to write in the negative moment column these values, as our sign convention is like this. So try to solve this at home. After calculating summation m, you have to calculate x bar. After calculating x bar, you have to calculate E, and after calculating E, you have to calculate Pn at toe and heel. So that is the final required answer. Okay, so in the next lecture, I will explain you the answers for this. So today we will stop here. Thank you very much.